Good morning, dear students. This is the next chapter we are going to start. We are going to have successive differentiation. In this, we are going to see how to use Leibnitz rule. Leibnitz rule for successive differentiation. Now, as I said in my previous video, this playlist is particularly for semester 1 engineering mathematics syllabus for Bachelor of Engineering degree of Mumbai University. You can take it as a crash course. Anyway, others also may use it to get clear with the concepts. These are all just mainly to clear the concept. Now here this Leibniz rule in successive differentiation, how we are going to use. First of all, what is successive differentiation? So if I give you y is say x raised to 6, just random example I have taken, and if I ask you say find the fourth derivative. So obviously to find the fourth derivative, we need to find first y1, which is 6x raised to 5, then we'll get y2, then we will get y3, and then we can get y4. What exactly we are doing in successive differentiation? In successive differentiation, what we are learning is how to get this fourth derivative directly without actually finding first, second or third derivative. Means if you are asked find 25th derivative, 27th derivative, is it feasible to find all these derivative first, second, third, fourth up to 25th? No. So this is a chapter which teaches you how to get directly nth derivative. And particularly I am going to focus here on Leibniz rule, which gives us directly nth derivative of a product. So we are going to see here nth derivative of product. Say u and v are two functions and we have to find nth derivative of uv. This Leibniz rule says this nth derivative of uv is u and v plus n into un minus 1 v1 plus n into n minus 1 upon 2 factorial un minus 2 v2 etc. And our last term is u into vn. You can see it's very easy to remember. If you remember binomial expansion of a plus b raised to n whole raised to n, it's similar to that. Don't just mug up this. See the pattern, it's very easy to remember. First function u, you have nth derivative, then n minus first, n minus second, etc. Whereas for v, I can say it starts with zeroth derivative. There is no such term zeroth derivative, but what I mean is the function v itself, no derivative. Then first derivative, second, third, and lastly nth term. And see the coefficients also. This is 1, means this is nc0, nc1, nc2, nc3, etc. So in general, you can see when you have the term, a term, say the coefficient is NCR, see properly. In that case, we are going to have here n minus rth derivative of u and rth derivative of v. This is the general term and you can remember the formula by this. Anyway, let's see some problems which are based on this Leibniz rule. What kind of problem we can have? So we'll have here one problem. We are given let y is sine of log of x square plus 2x plus 1. Then prove that x plus 1 whole square y n plus 2 minus 2n plus 1 into x plus 1 y n plus 1 minus n square plus 4 y n equal to 0. So first understand the type of the problem where we have to use Leibnitz rule, and then we will see how to use it. See, we are given y, a function of x, and whatever expression we have to find out, see properly. The expression is in terms of yn plus 1 and yn plus 2. So this kind of problem we are going to use Leibniz rule. Again I am telling you, we are given y, which is a function of x, and the expression which we need to find out is in terms of yn plus 1 and yn plus 2. So I'll give you simple way the steps. How can we find this? That first of all, we are given y is sine of log of x square plus 2x plus 1. This is our given function y. Now, I will tell you in short some steps, so you'll be able to solve this properly. My first step is find y1, and just pay attention. I will come back here, but find y1. Let's find y1. Now all of you know derivative of sine is cos, so it is cos of log of x square plus 2x plus 1 into derivative of log of this, which is 1 upon x square plus 2x plus 1 into derivative of this, which is 2x plus 2. Now whatever derivative you have obtained, after finding the derivative, please check, can you write this in terms of y? Yes or no? If you can write in terms of y, then I'll complete this step now. My step 1 is find y1 and write in terms of y if possible. So sometimes it may not be possible, but if possible, don't proceed ahead without that. Now I will have my second step. My second step is find y2, and again same way, now I will have write in terms of y or y1, whatever is possible. Don't forget this. Either you will have that we can write y1 in terms of y, whatever y we have found out, or if not, you will have y2 will be in terms of y or y1. So remember, writing in terms of y and y1 is very essential. Come back to this. This was our y1. Now I will go for next step. Now I said next step is find y2, means we have to differentiate. Now before differentiating, you can see it's better if we simplify. So I have here cos of log of x square plus 2x plus 1. You can see here 2 is common and this is x plus 1 bracket square. So 1 x plus 1 is cancelled. We are getting 2 upon x plus 1. This is what is our y1, and again I am telling you next step is find y2. I told you find a derivative. How to find is your choice, but the next step is find a derivative. Now you can see here when we want to find y2, if I continue the way we have obtained, we'll have to use here u upon v. But if I bring this x plus 1 here, I'll have to use u into v, and you can always understand u into v is better than u upon v. But again, it's your choice. I just told you find the derivative. How to find is your choice, but it's better to use uv instead of u upon v. And so I will first write this step. This is y1 into x plus 1 equal to 2 into cos of log of x square plus 2x plus 1. And now I'll go for y2. So you can try this. What is the derivative? uv. So this is y2 x plus 1 as it is plus y1 as it is. This derivative is 1 equal to derivative of cos is minus sine. So we have minus 2 sine log of x square plus 2x plus 1 into, again 1 upon x square plus 2x plus 1 into 2x plus 2. So as I said, our next step is find y2, and I wrote here write in terms of y or y1 if possible. Keep in mind, I will just go back and I will tell you one thing. When y, say it is in terms of e, if I give you e raised to sine inverse x, say y is e raised to sine inverse x, in that case when you find y1, it will be e raised to sine inverse x into derivative of sine inverse x, fine. But that e raised to sine inverse x is going to remain as it is. So you can understand, when your y is in terms of e, y1 will also contain the term e. So definitely whenever y is in terms of e, y1 you will able to write in terms of y. I am repeating, say if y is e raised to x, y1 will be e raised to x. So that means if y is e raised to any power, y1 will be e raised to that power into derivative of the power. So you can see here y1 will be y into something. So whenever it is in terms of e, you can always write y1 in terms of y, which I told you, write in terms of y if possible. Whereas if it is in terms of sine or cos, here it is in terms of sine, you can say y1 will be obviously in terms of cos, whereas y is in terms of sine. So we have not written y1 in terms of y. But when you go for y2, obviously now derivative of sine is cos and derivative of cos is minus sine, means y2 will be in terms of sine. So y2 you can always write in terms of given function y. Means whenever y is in terms of sine or similarly cos, though we can't write y1 in terms of y, we will able to write y2 in terms of y. If it is in terms of e, we can write y1 in terms of y. Understand these things, and you can see now very well what we are getting here is, after finding this y2, see what is the y2 we have obtained. Again, this is 2 is common, x plus 1 is cancelled, fine, we can do the simplification. But you can see here this is minus 2 sine of log of x square plus 2x plus 1, and you can see this part is nothing but y. This is our given y. You can check it. Our given y is sine of log of this. So y2 we have obtained in terms of y, and you can see this is minus 2y into, again here 2 is common, what is left, x plus 1, this is x plus 1 square, so 1 x plus 1 is cancelled. What we have is 2 upon x plus 1, and this 2 into minus 2, that is minus 4. So you can have this right hand side is minus 4y upon x plus 1. So you all can understand the simple calculations. So let's go for next. Whatever we have obtained, now I will rewrite the previous step. Whatever we have obtained, we had in the previous step y2 into x plus 1 plus y1, this is equal to minus 2 sine of log of x square plus 2x plus 1 into 2x plus 2 upon x square plus 2x plus 1. So as I said, 2 is common, 1x plus 1 is cancelled, this x plus 1 I can bring here, and I told you this is our y. And so what we are going to get is y2 into this x plus 1, 1 left we are bringing here, x plus 1 square plus y1 into x plus 1. This is, we have 2 common, minus 4. Again I am telling you this is y. And so ultimately we have y2 into x plus 1 square plus y1 into x plus 1 plus 4y equal to 0. This is one very important step we have obtained. Now, before proceeding, again I will try to tell you the general steps. What we are doing is, in the step 1, I am repeating find y1, and I told you write in terms of y if possible. Then our step 2 was sorry, find y2 and write in terms of y and y1 if possible. And finally, you are going to get the expression which is in terms of y, y1 and y2. This is the most important thing we have obtained. What we have obtained, get expression in terms of y, y1 and y2. So we got some expression in terms of y, y1 and y2, and after that our next, I will say, the last step. Our last step will be differentiating n times and applying Leibnitz rule. So I will say here step 3 is differentiate n times and apply Leibnitz rule. That's it. Just in these 3 steps, you are going to get the required result. Let's see how it works. Now when you are differentiating in times and we are finding nth derivative by Leibniz rule. So see the first term. Look at this. It is product of two functions and we are differentiating in times. What was the Leibniz rule? I told you. The Leibniz rule is, see, nth derivative of first term, second as it is, plus n into n minus first derivative of first term and first derivative of the second term. Let's see how it works now. See, nth derivative of y2, I hope you all can understand, it is yn plus 2, y2 we are differentiating in times, that is yn plus 2 into this v as it is, plus n into this derivative that reduced by 1, that is yn plus 1, into this derivative, that is 2 into x plus 1, that is v1, plus next is n into n minus 1 upon 2 factorial, that is nc1, nc2. Again this is reduced by 1, that is yn, and this derivative you can see 2, and you all can understand that's the int for first term, because when you go for next term, derivative of v, that is 2, is going to be 0. So this we found out. Nth derivative of first term, same way you can go for second and see what you will have. y1 into x plus 1, y1 differentiating in time, so it is yn plus 1, v as it is, same way it is. Next is n into this derivative 1 less, that is yn, this derivative is again 1. This is over. The last term we are differentiating in time, so it is yn. Now just open the bracket and rearrange the terms. What we are going to get, yn plus 2, look at this expression, last one what we obtained, x plus 1 whole square, plus what I will have here, 2n yn plus 1 x plus 1. Then here this 2 and this 2 is cancelled. We will have n square minus n into yn plus yn plus 1 x plus 1 plus n into yn plus 4yn equal to 0. Now just collect the terms of yn plus 2, then yn plus 1, then yn. yn plus 2, there is only one term, plus when I take yn plus 1 common, what is left with us? When you take yn plus 1 common, we have this 2nx plus 2n. Here also we have yn plus 1. What is the coefficient? X plus 1. Then when we take yn common, what we are going to get? N square minus n. This is plus n plus 4 and equals to 0. And now the last step I am leaving for you. Just simplify this. You are going to get the required result. Yn plus 1 into 1 plus n square. See what is common, what you are going to get, and accordingly you will get the RHS. So again I am telling you, these are the main 3 steps. Find y1, write in terms of y. Find y2, write in terms of y or y1. And third step is just differentiate n times and apply Leibnitz rule, and you can get the required expression. Now just one simple problem. I can leave it for you by telling you one important point. When I give you this, prove that 1 plus x square yn plus 1 plus 2n x minus 1 yn minus n into n minus 1 yn equal to 0. Look at this. Whatever steps I gave you, see properly. For these steps, when first thing was our given function, that was we had y in terms of x, that is y equal to fx, and because it was y equal to fx, we had these 3 steps. Find y1, then y2, etc. Now what can you see here? Here it is not y in terms of x, here it is x in terms of y. So our first step, because x is tan of log of y, try to write y in terms of x. So what will be y? It is tan inverse x. This is log, means it will be e raised to tan inverse x, and you can continue with the steps. And last point, in the previous problem, whatever we had to prove, that was the expression in terms of yn plus 1 and yn plus 2. So I told you the steps: find y1, write in terms of y, find y2, write in terms of y and y1, and you can see very well here, easily you all can understand, when we got the expression which is in terms of y2, y1 and y, and then we differentiated in times, this y2 becomes yn plus 2, y1 becomes yn plus 1, and we did this because the required expression was in terms of yn plus 2, yn plus 1 and yn. Now if the expression is in terms of up to yn plus 1, yn plus 2 and say yn plus 3. So if we want yn plus 3, so obviously here I told you find y2, we'll have one more step, find y3 and then differentiate n times and apply Leibniz rule, because if you have y3, after differentiating n times, you are going to get yn plus 3. Exactly same way, here the expression is in terms of only yn plus 1. This is yn minus 1, I'm so sorry. yn minus 1, yn and yn plus 1. So remember it is up to yn plus 1. So we don't need y2. Because if you differentiate y2 n times, we are going to get yn plus 2. This is only up to yn plus 1. So here how we will solve? We will have only y1, try to write in terms of y and directly go for the step, differentiate n times, apply Leibniz rule. You will get the required expression. So I hope you have followed this. So once again I am telling you, if it is up to yn plus 2, fine, go up to y2, apply Leibniz rule. If it is yn plus 3, go up to y3, apply Leibniz rule. This is up to yn plus 1, we'll have only up to I1 and we'll apply Leibnitz rule. So this is typical type of problems you can say in exam. I hope you understood. So we'll stop here. Thank you very much. And before I end, just one point I want to tell. Thanks a lot. I'm getting very nice response for these lectures. I have received so many mails, but just my request. Whatever mails I have received saying these lectures are benefited, students are understanding very well. My request is please put in comment box also, so even others can use these lectures and they can make use of all this. Okay, so thank you very much and goodbye.